This is modeling data with lines. Our objective today is to find a line of best fit for a scatter plot and use the line to interpret the data. Let's start with our vocabulary. A trend line is a line that you draw on a graph to approximate the relationship between data sets. If there is no association, you cannot draw a trend line. Notice that a good trend line is about halfway through the data. There's about the same number of dots below as above the trend line. So we have a table here that shows the circumference and height of a variety of trees. We're going to use a scatter plot to predict the height of a tree that has a circumference of 175 inches. Let's zoom this in a little bit. So, trying to make our whole graph fit on there. Perfect. Just about. Our heights will be our x-axis, and they go up to about 110. So I'm going to go by tens for my lines. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 150. All right, so that's height. And we need to go up above 200, so I'm going to go by tens again, and my last point will just be a little bit off my graph. There's 50, 100, 150, and 200 right there. So that's circumference. All right, so our first point is 1910. Right there. 3263. Right about there. 5772. About there. 43,111. Right about there. 75,150. Right there. 97,185. Right about there. And 110. See where 110 would be. And 214. About up there. So let's zoom out just a little bit. Now I can predict where my line would be. I'm just trying to get a very good line that fits for my data. What you always want is for your line to go through two of your coordinates. So my line is going to go through this one here and my point 97,185 right there. So I've got a couple above, a couple below. Perfect. Now we're going to take our 2 points. I went through 3263 and 97,185. And now we are just going to find the equation of that line, just like we always did before. So we're going to start with our slope. We subtract 185 minus 63 over 97 minus 32. That'll give me a slope of 122 over 65. Now I'm going to plug in one of my points. I'm going to use 3263. So y equals my slope times my x plus b, which is what I'm trying to find. So I'll multiply 122 over 65 times 32. And I get 63 equals 3,904 over 65 plus b. Subtract that 3,904 over 65 to the other side. And b is 191 over 65, which is about 2.94. So my equation is y equals 122 over 65 x plus 191 over 65. Now my original problem had asked us to predict the height of a tree with a circumference of 175. Now we're going to plug 175 in for y, because that's our circumference. So 175 equals 122 over 65, x, plus 191 over 65. Subtract over my 191 over 65, and then divide by 122 over 65, and x is approximately 91.67 feet tall. All right, in these two scatter plots, Nancy and Francesca each drew a different trend line to approximate the relationship between months employed and hourly rate. We're going to decide which trend line is better. So we look at these two trend lines. Nancy goes through 2 points, but she's got 6 points below her line and none above. Francesca doesn't go through any points. She's got 4 above and 4 below. Francesca's line is better because it goes through the middle more. All right, this scatter plot shows the results of a survey about the relationship between the number of hours spent reading and the number of hours spent watching TV. We're going to draw a better trend line. This one goes through 2 points. It's got 2 below and it's got 6 above, so it's not that good. We want to try to go through the middle. I think that if we draw a trend line right about here, we go through 2 points, we've got 4 above and 4 below. That is a better trend line. Realize there are multiple answers for these. All right, now we're going to make a scatter plot to predict the weight of a 10-month-old puppy. So here's the data that we have. We've got our months of puppy age and the puppy weight. So if I go down to my scatter plot, I'm going to do months along the bottom. And I'm going to make every other line a month. And up the side, I have to get up to 80 pounds, or 60-some pounds. So I'm going to make each line worth 4. So 4, 8, 12, 16. There's 20, 40, 60, and 80. So those are puppy weights. So let's plot our points. We've got 0.8, 1, 9.2, 2, 19.9, 3, 31.3, 4, 41.8, 5, 50.6, 6, 57.4, 7, 62.6, and 8, 66.4. All right, now we need to draw a trend line for this. I think that a good trend line will go right about here. I realize if you don't use a ruler, your line won't be very straight. My line goes through 3, 31.3, and 7, 62.6. Now we're going to find our slope. Slope equals 62.6 minus 31.3 over 7 minus 4. Our slope is 7.825. Now we plug this in. So plug in one of my y's. So let's use 31.3 equals 7.825 times 3 plus b. Multiply 7.825 times 3, subtract that to the other side, and b actually equals 7.825. So my equation is y equals 7.825x plus 7.825. Now it says to predict the weight of a 10-month-old puppy. So that means x would equal 10. Plug that in, and my y equals about 86 pounds for a 10-month-old puppy. Now we're going to use the same graph we just did to predict the weight of a 12-month-old puppy. So all I'm going to do is plug in x equals 12 to my last equation. I'll end up getting y is about 101.7 pounds. That puppy gets big fast. Now we're going to interpret the slope. Our slope was 7.825. This means that the puppy gains 7.825 pounds each month. And the y-intercept was also 7.825, but this means that the puppy is born weighing 7.825 pounds. Now we know that isn't true, but that's just what it means in the context of the problem. So now you're going to do practice 10.3, and then you'll do the trend line reflection worksheet to be assessed.